4,500 years ago, builders placed a massive stone slab weighing several tons inside the Great Pyramid. And yet, according to ancient writers, one person could open it with nothing but his bare hands. The Greek geographer Strabo, who left one of the most detailed descriptions of Egypt, claimed he saw it with his own eyes. In the 9th century AD, the Arabs passed right by it and didn't even notice. And to this day, there's no consensus. Was this door real or just a myth? So how was the entrance to the pyramid actually sealed? Did they use massive stone plugs that permanently blocked the passages? Or was there some cleverly designed mechanism with a movable slab, accessible only to those who knew the secret? If such a door really existed, it would have left traces. And here's the strangest part. Those traces are there, and somehow nobody noticed. We've got 3 starting points: Strabo's account, the design features of the corridors, and some mysterious holes in the bent pyramid. And toward the end, we'll try to get inside the head of the architect who designed all of this, because his logic might hold an unexpected answer.
For our analysis, we'll look at 4 pyramids, the 3 at Giza, and 1 at Dashur, the bent pyramid. Let's start with a question that seems simple, but has stumped generations of researchers. Basically, each pyramid could have ended up in one of 3 states. First option, fully sealed, like an airtight jar. Second, partially closed, but with access to certain chambers still available. And third, completely open. If the pyramid was fully blocked off, no door was needed at all. But if access was intended, then there had to be a way to open it. And that means we can try to figure out what problem the architect was solving. The key here is sticking to facts that are actually confirmed. Now let's look at how they built these pyramids. Each new level was laid slightly smaller than the one below. And that difference is what created the slope of the outer faces. It's kind of like 3D printing today. Layer by layer, the structure rises. Except instead of plastic, you've got massive stone blocks, weighing anywhere from 2 to 70 tons.
And here's the crucial point. When the builders reached the level of the entrance and the ascending corridor, all of that space was still open from above. No narrow passages, no low ceilings. They could freely place large blocks, shape them, and fit them precisely. The stones that today couldn't possibly be dragged through those tight corridors were put in place early on. Then the layers above were added, permanently sealing everything inside. So here's the real question. If construction goes from the bottom up, at what stage do you install the door? Hold that thought. It'll explain a lot later. Because understanding how a pyramid was built is one thing. Understanding how it was sealed is something else entirely, and that's where things get really interesting. British archaeologist Flinders Petrie, widely considered the father of modern Egyptology, was the first to seriously tackle this question. In his book, The Pyramids and Temples of Giza, he laid out a problem that still keeps researchers up at night.
After thousands of years of destruction, looting, and interference, reconstructing the original state of these pyramids is incredibly difficult. But Petrie's reasoning holds up. If the passages had been completely blocked from the entrance all the way to the smooth outer stones, no door would have been necessary. And yet, at least 2 ancient sources, either directly or indirectly, mention the existence of a door or steps leading to one. That fact alone raises questions. If everything was sealed shut, why mention a door at all? But logic alone isn't enough. We need testimony. And it exists, left by people who lived thousands of years after the pyramids were built. But if the door was real, someone saw it. And that leads to an even more uncomfortable question. Why can't we find it today? The 2 most important sources are Strabo and Diodorus Siculus. The latter was a Greek historian from the 1st century BC who traveled extensively and described Egypt in great detail.
Let's start with Strabo. In his Geography, he writes the following about the Great Pyramid. At a certain height, there's a movable stone that can be lifted, and behind it lies a sloping passage leading to a burial chamber. Think about that. That's weirdly specific, and it refers to a time long before Al-Mamun Tunnel, the route through which, supposedly, people first broke in. If Strabo laid it all up, where did that level of detail come from? Maybe he saw other pyramids, like the Bent Pyramid, and drew conclusions by analogy. But that's too specific to be a coincidence. Imagine an ancient explorer actually opening that door. He'd descend through the sloping corridor, pass right by the hidden entrance to the king's and queen's chambers, and end up in the subterranean chamber. Most likely, Strabo assumed that was the main burial vault. He had no idea about the other rooms deeper inside the pyramid. Now let's turn to Diodorus. He doesn't mention a door directly, but he does include an interesting detail. He's not describing the Great Pyramid, but one of its neighbors. Most scholars think he's referring to Khafre's pyramid, though some argue it's Menkaura's. Diodorus writes that steps were cut into one side of the pyramid. He doesn't specify where exactly the entrance to the Great Pyramid, or Menkaura's pyramid, was located. If those steps simply ended at a smooth outer stone, the whole idea of concealment falls apart, because the entrance location becomes obvious. There are a few possible explanations here. Either the steps were originally part of the design, leading to 1 or even 2 entrances, or by Diodorus's time, the entrance had already been breached, and the steps were added later for convenience. So here's the picture. Strabo explicitly describes a movable door in the Great Pyramid. Diodorus mentions steps that might have led to an entrance. But that's just a guess. Ancient texts alone can't settle this question. Yes, their descriptions are compelling, but we can only draw real conclusions after examining the structure of the pyramids themselves. And if everything we see next lines up with Strabo's account, we'll have to admit he wasn't making it up. He actually saw this door. Because words can be distorted or invented.
but stone is always an honest witness.
There's a reason some researchers are convinced the entrance corridor was once completely blocked. They point to distinctive grooves in the floor, arguing these were made when someone tried to extract granite plugs. But here's the strange thing. The floor is made of extremely hard granite, while the walls and ceiling are softer limestone. Simple question. Why would you chisel the hardest surface when there's much softer material right next to it? It would have made far more sense to work through the walls or ceiling. On top of that, as Petrie noted, if plugs had been systematically removed, this would have inevitably left marks on the surrounding surfaces. The walls and ceiling would show damage, but there's nothing like that. There's one more detail that breaks this theory. Let's say someone managed to extract the plugs before the Arabs began their intrusion. Then why would that person have stopped at the triangular block concealing the entrance to the ascending corridor, the very block that only shifted during the excavation of Al-Mamun's tunnel? It's a dead end. For logic, yes, but not for people who decided to use brute force.
Around 820 AD, the Arabs tried to get inside the Great Pyramid. From the outside, there wasn't the slightest hint of an entrance. And they didn't use ordinary tools. According to medieval Arab chronicles, Al-Mamun's men built fires directly against the stone wall, heating the limestone to extreme temperatures, then rapidly cooled it with vinegar. The thermal shock cracked the stone from within. There'd be a dull thud, chunks would break off, and workers in the cramped space would scoop out the hot debris with their bare hands, choking on smoke and acrid fumes. Brutal and slow, but it worked. Livy described a similar technique when writing about Hannibal's crossing of the Alps. The Arabs simply applied an ancient method to their own challenge. Meanwhile, the pyramid's exterior was working against them. The smooth white casing, the smooth outer stones, completely hid the real entrance, which sat roughly 56 feet, 17 meters, up on the north face.
Although smooth isn't quite the right word. The Arab historian Abd al-Latif al-Baghdadi saw the pyramids around 1200 AD, long before the casing was stripped for building materials in Cairo. And he describes something quite different. The stones, he says, were fitted so tightly that you couldn't slip a needle between them. But the real surprise, the entire surface was covered in inscriptions. So many that, as al-Baghdadi wrote, copying them all would have taken more than 10,000 pages. So this wasn't just a white surface, it was an enormous stone book. And if the door existed, it was part of that text. Finding it among thousands of symbols would have been nearly impossible. From below, the surface looked completely uniform. So Al-Mamun's men started cutting a horizontal tunnel, roughly 23 feet, 7 meters, below the real entrance. After chiseling through about 89 feet, 27 meters of stone, they unexpectedly hit the descending corridor leading down. That hit seems almost miraculous. 89 feet of solid rock and a direct strike. If they'd been off by just 3 feet, 1 meter, the tunnel would have missed entirely. They probably had some kind of information about the interior layout. Local people may have passed down rumors, and some of them turned out to be right. Once inside, the Arabs went down the corridor and found a branch, an ascending passage blocked by granite blocks. They only spotted it because the concealing triangular stone had shifted during the work. So here's what that tells us. If Strabo really had been inside, those plugs were completely hidden in his time. How well hidden? Petrie measured the gap between the concealing block and the neighboring ceiling stones, about 1/50th of an inch, roughly half a millimeter. That's a level of precision we associate today with high-quality optical surfaces. The ancient craftsmen fitted that limestone block so perfectly that it literally blended into the surrounding masonry. And they didn't do it for aesthetics. They did it to hide the passage. From there, the Arabs made a smart move. They started chipping away the softer limestone around the plugs and worked their way into the ascending corridor and the grand gallery. Simple logic. It's easier to go around an obstacle through soft material than to try to destroy the granite itself. When they surveyed the interior, it became clear that both corridors connected to the outside somewhere above. They were standing in the grand gallery, a soaring ceiling about 26 feet, 8 meters high, stretched upward. The walls rose in stepped layers that leaned inward, and all of this grandeur had been hidden by a single disguised stone. Climbing back up the descending corridor, the Arabs broke through the blocks from inside and found the original entrance. That's how the chroniclers tell it, though they weren't eyewitnesses themselves. But here's what matters. These same people had already dealt with granite plugs and preferred to go around them through the walls. So we can't claim the original entrance was permanently sealed with stone plugs.
And that brings us to the main question. What actually closed the entrance? Not just a door, but a control mechanism. Something that determined who got in and what they'd find. A door like that could open easily from the outside, but resist almost any attempt from the inside. And when someone finally broke in, they simply destroyed it. The answer might be hiding in the only place where such a structure survived. If we put all the observations together and account for the fact that no granite plugs, intact or broken, were found at the entrance, an interesting pattern emerges. The lower part of the ascending corridor and the entrance to the Queen's chamber were most likely blocked with plugs, but the main entrance itself seems to have been simply disguised. Whoever found it got inside without much resistance and headed straight for the subterranean chamber.
There's a sense that the underground vault was a kind of decoy for anyone who cracked the secret of the entrance. This isn't physical protection, it's psychological. Imagine a door with a weak lock and something valuable lying in the hallway. The burglar grabs the loot and leaves, never suspecting that the real vault is hidden deeper inside. It's possible that over time this strategy stopped working, which may have contributed to the abandonment of increasingly complex pyramid construction. But we'll come back to final conclusions later. For now, let's stick with the facts. As for the other two Giza pyramids, Khafre's pyramid has its entrance coated with a reddish plaster that smooths out irregularities in the masonry. And here Petrie's logic kicks in again. If heavy plugs had been dragged through the corridor, they would have inevitably scraped off that coating. But it's still intact.
That means the entrance may not have been blocked with plugs at all. Instead, it could have been closed with a movable element that left no damage. But that raises the next question. What properties would such a door need to have? It had to open manually from the outside, and it had to be so precisely disguised that it would remain invisible for millennia to everyone except those who knew how it worked. And this is where we hit the most interesting part. To understand what it might have looked like, we need to find a place where a similar structure survived. And there is one, just one, on the entire planet. At Giza, almost everything is destroyed, making it hard to figure out the original mechanism. But at Dashur, the situation is different. Some things survived. That's why the bent pyramid is our only chance to see a possible door in something close to its original form. The dates matter here. The Great Pyramid dates to roughly 2580 BC. The Red Pyramid around 2590 BC. The Bent Pyramid around 2600 BC. The gap is only about 20 years. By pyramid building standards, that's practically the same era. The techniques and experience developed at Dashur could easily have been refined and reused at the Great Pyramid, possibly even by the same architect.
Sneferu's Bent Pyramid at Dashur has two entrances. Both are above ground level and lead down to two chambers. One at ground level, the other deeper. One corridor runs from the northern entrance, the other from the western one. Inside, they connect. But we're interested in a very small section, the first few feet of the northern entrance. Why this spot? Because it's one of the few places where the smooth outer stones have survived almost completely around the doorway. Here, we can examine the frame and try to understand how the entrance might have been sealed. For researchers, this is a stroke of luck. In other pyramids, the entrances are either destroyed or damaged beyond recognition. Petrie noticed marks on this frame that hinted something. A movable door, similar to the one Strabo described, may have existed here too. The frame has two holes, roughly fist-sized, about 3 to 4 inches in diameter. When describing them, Petrie used the cautious phrase, apparently. Given his meticulous nature, that's significant. He was likely relying on someone else's observations and didn't want to draw firm conclusions without verifying them personally.
And the caution was justified. The holes have different depths. The western one is about 7 inches, the eastern one about 11 inches, nearly double. A strange asymmetry. And here's the really unfortunate part. After a 1964 study by Maraiolio and Rinaldi, those holes were filled with concrete during restoration. There's no way to re-examine them now. Looks like a case where restoration did more harm than good. So the bent pyramid gives us an idea of what the door might have looked like. But as soon as we ask how it actually worked, things get a lot more complicated. Now, here's where things start to fall apart.
On paper, Petrie's idea sounds brilliant. A massive stone door, perfectly balanced, rotating on metal pivots, something one person could actually move. He figured the holes on the sides of the frame were sockets for bronze pins. You'd embed the pins in the door, set it in the frame, and carefully calculate the center of gravity,
so the front was just a tad heavier than the back. That slight imbalance would hold the door shut, front edge tipping down, back edge pressed tight against a groove cut into the ceiling. And yet, because the whole thing was nearly in balance, a single person could swing it open. There's even a groove in the ceiling that fits this idea, a slot where the back of the door could slide in. Petrie also thought there might have been a small wooden panel attached at the top and bottom, though the floor is destroyed and there's no trace of a lower fastening.
And this isn't just a wild guess. In the Temple of Luxor and in several New Kingdom tombs, archaeologists actually found real stone doors on bronze hinges. Granite and alabaster slabs weighing hundreds of pounds, rotating on bronze pins set into stone sockets. These aren't hypothetical. They existed and they worked. So the Egyptians clearly knew the concept. The question is whether the builders of the 4th dynasty could have scaled it up to fit a pyramid entrance. At first glance, it all sounds pretty elegant. But once you try to picture it in real life, it gets messy fast.
First, there's the oversized lintel, the large stone beam above the entrance to the bent pyramid. If the whole point was to hide the entrance, you'd expect that beam to blend in with the rest of the smooth outer stones. But it doesn't. It's noticeably bigger, almost like a signpost saying, "The door is right here." You could argue it the other way. Maybe they weren't trying to hide the entrance at all, just to mark it. In that case, the ceiling was more decorative than functional. Most likely, that oversized beam was a deliberate choice to highlight the entrance, especially since the bent pyramid only has 2 of them. Second, and this is the real killer, the geometry just doesn't work. The door is wider than its opening. When the bottom edge lifts up, the top has to swing back along an arc. But the upper part of the frame simply doesn't allow that motion. The door would jam the instant you tried to open it. It's like trying to open a hatch that's bigger than the hole. No matter what angle you try, something's going to get stuck.
Then there's the installation problem. If the gaps between the door and the frame are razor thin, which they'd have to be to hide the joint, getting the door into position in the first place becomes a nightmare. You can't just secure one pivot and rotate the door so the other pin slips in. It'll hit the edges. It's like trying to maneuver a big couch through a narrow doorway. You just don't have the angle. You could imagine another approach. Mount the bronze pins in the frame first, then lower the door onto them through special slots. That might make installation possible. But the jamming problem doesn't go away. The only way around it would be to reshape the top of the door into a slight curve and place the pivot right below the widest point. Then it would move almost like a wheel, rolling around its axis. But this is insanely hard to pull off in stone. The radius of that curve has to precisely match the distance to the pivot. The slightest deviation, and the whole mechanism locks up. Stone doesn't forgive that kind of imprecision.
There are a couple of alternative designs that other researchers have proposed, and they're worth a quick mention. One idea is a wedge door, basically a big pie-shaped stone that swings inward, fitting into both the ceiling groove and the section of floor that's now missing. The problem? It could only open part way before hitting the ceiling of the passage. Anyone trying to get through would have to squeeze under it in a U-shaped maneuver. Not exactly practical. The other idea is a slab door, where you push the bottom of the stone inward first, then lift the whole thing up and prop it in place. But that design is even worse, too heavy, too unstable, and honestly kind of dangerous. So every option, whether it's Petrie's elegant pivot system or the cruder wedge and slab designs, runs into the same wall. The stone jams. A door that size simply can't swing freely in a tight opening without hitting the frame. Now, if we try to apply this question to the Great Pyramid, the situation is even tougher. Everything there is so damaged that any possible traces of hinges or mechanisms are simply impossible to spot, even if they once existed.
We already know the 9th century Arabs couldn't find the original entrance and broke in below it. The marks from their work are still visible around the entrance. But here's the thing. If we mentally transplant a structure like the one proposed for the bent pyramid, with a properly calculated center of gravity and a slightly rounded top to prevent jamming, we get exactly the type of door that could have actually worked in practice, and it matches Strabo's description. It's hard to believe Strabo just happened to guess the one design that would actually function, a design where the stone matches the angle of the smooth outer casing, stays invisible, holds itself shut by its own weight, yet opens with a push of about 50 to 60 pounds of force. He describes the interior exactly as someone would see it if they didn't know about the hidden ascending corridor. He noticed exactly what was accessible and missed exactly what was deliberately concealed. If this door design doesn't really work in the bent pyramid, then what were those holes actually for? Right at the entrance to the passage, there's another detail, a hole in the floor. And some researchers have proposed an entirely different interpretation of the whole setup, based specifically on this feature. Let us start with those upper holes, the ones at different depths. The difference is roughly the width of a palm, about 4 inches. That gap would allow a beam to be inserted into the frame. On top of that, there are additional sockets in the walls that could have been used to create mechanical advantage. A rope would be threaded through them in various configurations, then wound around a windlass, basically a simple rope and beam winch mounted at the entrance. A winch like that could have been used to raise and lower heavy loads through the corridor during construction, or for carefully lowering stone plugs during the final sealing phase. Without something like it, the work would have been insanely dangerous. Any load heavier than what a few men could hold back might break free and go sliding down. It is roughly like trying to lower a grand piano down a steep staircase without a winch, except here we are talking about multi-ton blocks.
Now, here's where the ceiling groove starts to make a lot more sense. Think about how hard it would be to control a heavy plug in a sloped passage. You can't just tip it into the shaft and hope for the best. Instead, with this groove, the block could first be raised to the entrance level and slid in horizontally, pushed straight into the passage on a flat plane. When it reached the back edge of the groove, its own weight would tip it forward, and it would start its descent down the corridor. At that point, the back end would be held by a rope wound around the winch beam mounted in the frame. Without that groove, the block would have had to be positioned immediately at the corridor's angle. The slightest miscalculation, and it would jam or slip away. And here's a clever detail about the floor. It could have been left intact until the very end. When they were ready to seal the passage, they'd remove the top layer of the floor, and that missing section would act as a stopping point, preventing the plugs from sliding further down the shaft than intended.
The bevel at the entrance also played a key role. It allowed precise control over how deep the plug sat. You'd insert the plug from below, tilt it back into the frame, and check the fit. If something was off, you'd pull it back out, trim it down, and try again. Little by little, you'd shave away material until you got a perfect fit. That's how you could achieve the kind of precision we see in these structures. To be fair, this doesn't really fit with another detail we talked about, that oversized stone beam above the entrance, the one that seems to draw attention to it rather than hide it. If you're using this entrance as a construction access point with a winch, why would you also make it so conspicuous? For now, these two facts are hard to square. And if this version is correct, then the holes aren't traces of a door at all. They're traces of a construction mechanism, a temporary winch system used during building, which means we've been looking for a door where there may never have been one. But here's what really matters. The bent pyramid essentially looks like an experimental version, a rough draft where solutions were tested before the real thing. The winch system, the ceiling groove, the removable floor, the bevel for fine-tuning the fit, all of it feels like prototyping, trial and error in stone. And that leads to the big question. What changed in the architect's mind when he moved from this draft to the Great Pyramid? Did he keep the door concept? Did he abandon it? Or did he turn it into something else entirely? And this is where things get far more interesting, because maybe the door was never built for the engineers at all. Even if we figure out the mechanics, it still won't answer the main question. Why was any of this necessary?
Let me be upfront about something. What follows isn't fact. It's my interpretation. I don't like building hypotheses without saying so first, so I'm being straight with you. This is just my way of trying to figure out the logic of an ancient engineer, drawing on human behavior that, strangely enough, hasn't changed much in thousands of years. Sure, trying to get inside the head of someone who lived 4,500 years ago is risky business, but let me show you how I got here. Let's start with one assumption. There was a movable door in the Great Pyramid. Just imagine it existed. Then the question becomes, what could it do that a solid blockage couldn't? For the ancient Egyptians, this may not have been purely an engineering decision. The word they used for a pyramid entrance, Ra-nen-Ra-Stau, translates as mouth of mystery or lips of the hidden one. That alone suggests they saw the pyramid as a living body, with the entrance playing the role of a mouth through which rituals passed. In the pyramid texts of the 5th and 6th dynasties, there are spells addressed to the door of heaven and the leaves of the horizon that must open before the pharaoh. A solid wall can't open.
A sealed passage won't let anyone through. But a door can. So a movable entrance may not have been an architect's whim, but a religious necessity. The pharaoh needed a path that could be opened. And that shifts the entire problem to a different level. But we've been looking at this door as protection the whole time. What if it was the opposite? What if it wasn't protection, but a trap? People are naturally drawn to anything that feels hidden or off limits. Maybe that's exactly why this topic hooks us. Imagine this. You're walking through a forest, and you find a hidden door in a moss-covered hill. It's unusual, intriguing. Naturally, you decide to look inside. Behind the door, a short corridor that ends in a dead end. You think, why build all this for just a few feet? There must be more. You start searching, tapping walls, and eventually find a hidden passage. Classic scenario, straight out of an adventure movie. Now change the conditions. Behind the door, a long sloping corridor that descends deep underground, leading to a subterranean chamber. You've already come a serious distance. You already feel like you've gotten to the heart of it. And at that moment, the thought that you should keep looking might simply never occur to you. You were given a big enough adventure to believe this is the prize. Now, a third scenario. There's no door at all. The entrance is completely hidden and sealed shut. Then, you're working blind. Remember the Arabs? They started cutting through a solid wall. That means they already had some clues. Most likely, they knew that entrances to pyramids like this are usually on the north side, roughly in the middle. And here's where it all leads. No matter what the builders did, sooner or later, someone would get inside. The designer knew that. And if his goal was to divert intruders away from the real chambers, the logical move was to give them a reward, a chamber located deep underground, right where you'd expect to find it. The person discovers it, feels satisfied, and leaves. Meanwhile, the idea that the real chambers are higher up, inside the body of the pyramid, was too unconventional. It didn't fit the usual pattern, so it didn't attract attention. And apparently, it worked. For over 2,000 years, from the time of Khufu to the era of Al-Mamun, the king's and queen's chambers remained untouched. The Greeks went inside. The Romans did too. They all descended, reached the subterranean chamber, and were sure, mission accomplished. Nobody looked higher. The passages to the upper rooms stayed sealed and might have remained a secret forever, if not for a single accident. One stone, one small shift, and the entire system of deception collapsed. This project was designed to last for ages. Inside the pyramid, they created a multi-layered system, an entrance leading to a false target, a perfectly fitted concealing block, accurate to 0.5 millimeter, hidden plugs, behind an invisible turn. But this wasn't just stone protection. It was a system built on psychology. Each layer provided just enough information for a person to think, "I found everything there is to find," and stop.
Anyone who reached the subterranean chamber after a long descent through darkness felt like a conqueror. They'd reached the goal, and the last thing that would have crossed their mind was to go back and start searching for hidden passages somewhere above. It turns out the door served an entirely different purpose. It didn't protect, it directed. The ancient architect was essentially playing a game against future tomb robbers, and that game lasted thousands of years. He won round after round, until chance decided everything. Not a mistake, not a break-in. A stone simply shifted. A game that played out over thousands of years ended because of an event that couldn't have been predicted. 4,000 years of flawless strategy, and one accident changed everything. It might be one of the most impressive matches in history, and one we'll never fully be able to judge.